First of all, we're going to be careful to read a question carefully because this says solve, not prove. So some questions say prove. A prove question, you'll draw your line, work on left and right hand side separately. A solve question, you're going to be able to work on both sides. Okay? How do solve questions become a little bit different in an identities unit? Well, in part A, do you see that you have a sin x and a cosecant x? Two different ones. We can only solve easily if it's the same one. But can you change cosecant x? Yes. So that'll be step one. That's the only identities part. The identity part of this question is that you change the cosecant to 1 over sine x. And I did it very deliberately and slowly by just putting brackets and change it to 1 over sine x. Because lots of times students screw up with the 2 out in front. That 2 out in front is technically a 2 over 1, right? How do you multiply fractions? This will be 2 sine x equals 3 plus 2 over sine x. And the number one mistake in this question is, since students know the sine x needs to be at the bottom, sometimes that drags the 2 to the bottom with it. You're like, oh, just bring the 2 down to the bottom too. No. That 2 is out in front. If I multiply it by 1 over sine x, I get 2 over sine x. And now solving this involves some skills from grade 11. How did you solve equations when you had fractions in grade 11? You got rid of that fraction. You didn't like that on the bottom. What could I do to get rid of the fraction on the bottom? I could multiply by sine x. But if I multiply this whole side by sine x, I need to multiply this whole side by sine x. What would I get? I would get here 2 sine squared x. And here I would distribute. I'd get 3 sine x. And here when I multiply it cancels out, I just get plus 2. So the fraction idea connects with grade 11. Now it's a quadratic equation, also from grade 11. How do we solve quadratic equations? We make one side equal to 0. And then you'll either factor or use the quadratic formula. This one you can factor. If you did attempt to factor, if you don't like factoring these ones, go to your quadratic formula. But this one's not hard to factor because the first one being a 2 only gives you one option there. It has to be 2 sine x and sine x. The last number being a 2 technically gives you two options. It's either 2 and 1 or 1 and 2. And it's going to make a difference. Should you do 2 and 1 or 1 and 2? If I did 2, here I'll do it in green here. If I did 2 and 1, do you see your inside's 2 and your outside's 2? Does 2 plus 2 ever make 3? No. So I'll take out my eraser. But if I had put the 2 here and the 1 here, now my outside is 4, my inside is 1. 4 and 1 could make 3. I need a negative 3. Does it make sense? I'd want a minus 4 and then a plus 1 to get a negative 3. And if I double check this, sure enough, after I factor, I always multiply it out in my head and it matches up. This then tells us, and split it right here, that either sine x equals negative 1/2 or sine x equals 2. Is a half on your pie plate? Yes. What family? Pi over 6 family. Negative, which quadrants? Quadrant 3 and quadrant 4. Is 2 on your pie plate? No. But this is still non-calculator. Why? Bigger than 1? All you have to write is not possible. I feel really good that I want to be done, but I'm always going to double check. Did they ask between 0 and 2 pi? Because this is my answer is between 0 and 2 pi. So I go back to the question a little scared. Oh, I'm happy. They asked between 0 and 2 pi. I don't have to change any answers. Circle that. It seems like the textbook always, you get to the end and you're like, oh, they make me do one more step. Between negative pi and pi. I'm like, oh, you're kidding. Love it when they just keep it between 0 and 2 pi. So this is our answers. Okay? Part B. Did I make that already separate? I did. Thanks. Part B, sine x equals cos x. You have two methods that you could do this. One, you could just say, I know from my circle. There's only two places on my circle where the x coordinate and the y coordinate are the same. Where is that? Right here, right? Root 2 over 2, root 2 over 2. And where else? Right here where they're both negative, right? So this one, you could do that strategy. And you're done. Feels like kind of cheating. I just looked at my pie plate and said the answers. If you wanted to do this with identities, you would do the following. What happens if I divide both sides by cos? If I divide this side by cos, I would get this. If I divided the right side by cos, I'd get 1. What can I change sine x over cos x to? I can change it to tan. So now I'm asking, what family does tan x equal 1? Pi over 4. And it's positive. Which quadrants should you look in? Quadrant 1 and quadrant 3. Same answers. This feels more algebraic, doesn't it? The right side feels more like I did something. The first time I'm like, I just knew. Feels like they're going to take off marks for not showing enough work. All right, so circle number 10. Tomorrow, you're going to get your other quiz back, and we'll start our advanced proving strategies.